Hello all. In today's sessions, we'll discuss value of torque and angle of twist when shafts in series. Okay, when two shafts are in series during motion transmission. Okay, then we have some correlation between torque and theta. Now, what is that correlation? The torque in that particular shaft equal to torque at one end and torque at second end. That means these are the shafts which are connected to each other. So if you twist this shaft, that is, if you twist torque, shaft number 2, then automatically your shaft 1 will get twisted, and that value of twist is same. Okay. Then again, next is the value of torque will remain same. Then next is angle of twist. So we can say that overall deformation of that particular shaft, angular deformation of that particular shaft is nothing but addition of twist at shaft 1 and addition of twist at shaft 2. Okay. So we can write total angle of twist for that particular shaft equal to TL upon GJ into 1, that is angle of twist for shaft 1, plus torque into length upon modulus of rigidity into polar moment of inertia for shaft number 2. So that equation will become torque into length upon modulus of rigidity into polar moment of inertia for shaft 1, TL upon GJ of shaft 1 plus TL upon GJ of shaft 2. Okay. Now let's take one example, and based upon that example, we'll discuss. So this is the case where we are considering only two shafts. Suppose say three shafts are connected to each other. So what will happen if we consider three steppered shaft with a diameter of D1, D2, and D3 and length of L1, L2, L3? What will happen? Torque at shaft number 1 will be TD plus TC plus TB. Okay. So at section 1, this is the addition or subtraction of torque based on the direction. Torque at second section will be TD plus TC. Okay, addition and subtraction based on direction. And torque at section 3 will be only TD, because this shaft number 3 is only subjected to torque at section D, whereas shaft number 2 is subjected to torque at section D plus torque at section C. And shaft number B, that is shaft number 1, is subjected at point B, torque of B plus torque of C plus torque of D. Again, it is depending upon direction. Okay. So we can use right hand thumb rule. Based on that right hand thumb rule, we can define the direction. Okay. So that part we will discuss. Now look at the sign conventions. Okay. So we can say when there is a clockwise, when we can take clockwise torque on left hand and anti-clockwise torque on right hand, when shaft rotates in the direction of, suppose say if shaft rotates in, if you apply left hand thumb rule, okay, so what will happen if you apply left hand thumb rule? When the rotation is axis, rotation of that torque is away from the axis, then it will be negative. When it is towards the axis, then it will be positive. Okay, so these are the rotations. So anti-clockwise, clockwise torque on left hand and anti-clockwise torque on right hand, if then shaft is considered as a positive. So we can apply that rule. Okay. And again, anti-clockwise torque on left hand and clockwise torque on right hand, then that shaft is considered as negative. So these are the direction of rotation they have considered. So observer position, if you consider observer position from this end, then it will be towards the object. Again, from this end, again, it is towards the object. From this side, it is away from the object. Again, from this side, it is away from the object. So that considerations they have taken. Now next is, we'll take one example, and based on that example, we'll discuss whether that shaft is rotates in clockwise direction or anti-clockwise direction. Okay. Now the data is given. Determine the total angle of twist in step shaft. The diameter of portion is given 50 mm and length is given 4 meter for section AB, whereas for section BC, they have mentioned the length 2 meter and diameter 20 mm. The shaft is twisted by torque T with magnitude of 200 Newton meter, which is applied at point C. Take modulus of rigidity 80 into 10⁻³ megapascal. So that data is available. Okay. Now we have length for section AB, which is 4 meter, that is 4000 mm. Diameter of AB is available 50 mm. Then we have length for section BC 2 meter, that is 2000 mm. Diameter for section BC is available 20 mm. And torque is given 200 Newton meter, that is 200 into 10⁻³ Newton mm. Then we have G value, modulus of rigidity 80 into 10⁻³ megapascal. So you can calculate polar moment of inertia for section AB, polar moment of inertia for section BC. Okay. So that polar moment of inertia for section AB will be pi by 32 d raised to 4. So pi by 32 diameter of section AB is 50 mm. So you'll get that value of polar moment of inertia 613.59 into 10 raised to 3 mm raised to 4. Whereas polar moment of inertia for section BC is pi by 32 d raised to 4 BC. That is pi by 32 into 20 raised to 4, which is 15.708 into 10 raised to 3 mm raised to 4. So what we have discussed, the angle of twist for that shaft is nothing but addition of theta for section AB plus addition of theta for section BC. So you can calculate theta value, TL upon GJ at AB plus TL upon GJ at section BC. So torque value, now look at the direction. They have taken clockwise. If you apply from this side, if you consider applying right hand thumb rule, curl finger will indicate the direction of rotation, and the direction of rotation is nothing but in anti-clockwise direction. Okay, so this anti-clockwise direction they have taken as a positive, clockwise as a negative. So it is towards the shaft. So theta is torque value is positive, 200 into 10 raised to 3. Then what we have? We have G value 80 into 10 raised to 3. Length is available 4000 mm, 2000 mm, 4000 for section AB. Then J value we have calculated for section AB 613.59 into 10 raised to 3. Length for section BC is available 2 meter, that is 2000 mm, and J value for section BC, polar moment of inertia for section BC is available 15.708 into 10 raised to 3. So if you put all these values, then you get theta in radian, which is 0.3346 radian. We can convert that value in degree, multiply by 180 upon pi. So you get that theta in degree 19.172. So this is the first case where we have taken that direction of shaft anti-clockwise. Okay. Now look at the second problem. Now they have given the direction clockwise. So observer positions considered from this side. So direction of shaft is theta, that torque value they have taken. So torque at section CD is 880, at section BC 2200 Newton meter, and at section AB it is 3300 Newton meter. So step shaft is given. The diameter are 80 mm, 60 mm, 40 mm. The length of each part is given 0.5 meter, and modulus of rigidity is given 80 GPa. Okay. So net addition of torque, if you consider for section AB, what is the torque? It is the addition of all the values of torque. That is 880 plus 2200 plus 3300, which is 6380 Newton meter. For section BC, it is the addition of 2200, that is torque at point C plus torque at point D, which is 3080 Newton meter. And at section CD, it is 880 Newton meter. Okay. Now, polar moment of inertia we have calculated. At section AB, it is pi by 32 d raised to 4, which is pi by 32 80 raised to 4. Diameter of section AB is 80. So that value is 4.021 into 10 raised to 6. For section BC, it is again pi by 32 60 raised to 4. For section CD, pi by 32 40 raised to 4. So it is 1.27 into 10 raised to 6, 251.33 into 10 raised to 3. Now look at now they have taken these values are actually negative, minus 880, minus 3080, minus 6380. Okay, but basically we are calculating theta. Okay, so if we consider all these values, so finally you will get theta in negative, and theta will not be negative. That's why they are not applied that direction of torque while calculating the value of theta. Okay, so theta TL upon JJ they have taken. All the torques are in negative direction, so they have taken as it is that values. Torque is 6380 Newton meter. Convert that value into Newton mm. 6380 into 10 raised to 3 Newton mm. Length is 500 mm. Each section is of 0.5 meter. That is, convert that value of 0.5 meter into meter, 500 mm. Then we have G value 80 into 10 raised to 3, and we have J for section AB 4.02 into 10 raised to 6. Okay. Similarly, we can put that value for section BC, for section CD. So if you put that value for section BC, you get theta 0.015 radian, and for section CD, if you put torque 880 into 10 raised to 3 Newton mm, length 500 mm, G value 80 into 10 raised to 3, and J 251.33 into 10 raised to 3, you will get that theta 0.0219 radian. So if you consider addition of theta, then you will get final value of theta 0.046 radian, theta of section AB plus theta of section BC plus theta of section CD. And if you convert that value of theta in degree, then it will be 2 degree. Okay, 2 degree and 2.41 degree. That is the value of theta. Okay. So this is all about calculation of angle of twist. Okay, when shafts are in series. Thank you.